Class. So using this formula, let's all say it simultaneously. I'll go 1, 2, 3, and then say it, right? What the time is. Ready? 1, 2, 3. 1.116. 1.16? 1.106. Is there a general agreement? Yeah? So we solve for t? Yeah? And then how about here? What is it here?
Why'd you guys round it down?
Is it 7?
Yeah.
Oh my gosh. They think it should round up, you know. Luckily it's a very small part, right? Okay. And then what is this velocity? What is this divided by this? 7.34. Yeah? So that should be the velocity. Let's try it. Okay. Okay, so 7.34. Are you guys ready? Are you ready?
Yeah.
Drum roll, please. There we go. All right. So now all you have to do, you've shown your work. You've got the little T-chart, yes? You've written Vernier trajectories on the top, haven't you? Okay. You've done one of them. All you need to do now is move this guy further or whatever to try a different distance. And then what needs to be recalculated now? Do you need to figure out the time? Has the time changed?
No.
No, time hasn't changed because remember the two cannonballs dropped.
It's just the horizontal displacement.
Only the horizontal displacement. So all you have to do is put the new distance in here, right? And that divided by the same time is going to give you, yeah? Does that make sense?
Wait, so anything that drops from 6 meters?
All right, let's stay.
Yeah, it doesn't matter, right? If it can go 2 inches or 2 miles, and it'll still hit the ground at the same time.
Really?
Yeah. We think that's true, right? That was that whole demonstration and everything. Okay, now, if there's air friction and it can fly, sort of, yeah. Yeah. Okay, so for the Vernier Lab then, when I set you loose to do labs, that's one of them, and all you need to show is your calculations for these things. Okay, the second one, let me just show you the second one. Okay, so, and that's not where it is. Very unhelpfully. How about my desktop? It is in a folder called New Vernier. Okay, so you'll see a thing that says New Vernier, and the second one is Vernier 2. Okay, now Vernier 2, the first one was the object just sat still and just said, hey, send that aid parcel to me, right? But the next one is, if you watch, it's like, there we go, right? The car is moving. How do you make a car move on these in case you want to make your own little simulation? Well, I'm going to double click on there. Notice that the X position of this thing, it's called polygon number 8, or something like that, body 8. Okay. Notice that its position is 2 plus input 9 times time. Time is a system variable that is just the time in the simulation, right? So that's just velocity times time, isn't it? So whatever we type into input number 9 is going to be the speed of this thing, and there it is. So we can make it go any speed we want. It can go zippily, right? So here, let's watch it go. Yo, there we go. Okay, almost as if this thing doesn't want the aid parcel, right? Okay, now, how do you hit this target? It is moving. What do you have to do? You can't shoot for where it is. You have to shoot for where it will be. So method number 1, and a long time ago I thought this was the only way it could be solved, was that don't you know if it's 2 meters away, and if in this case it's 4, whatever's in this box, right? You can figure out the distance that it's going to be. And the distance that it will be is 2 plus 4 times 1.107. Aren't you going to hit it at the same time? Yeah, you'll always hit it at 1.107 seconds, right? Okay, so it's going to be 2, because it's already at 2, plus every second that goes by 4 meters farther, right? That's where it's going to be, so you can figure out what this is and then do the same thing. That's method number 1. Okay, Method number 2, some kid thought this up. I can't remember who it is, so I'm going to claim it as my own idea. Okay. Method number 2 was that the kid said, oh, it's really easy. I just shoot for where it is. In other words, he shoots, it's at 2 meters. He just goes 2 divided by 1.107. And then he adds the speed of the car. And I said, that doesn't work. Well, damned if it didn't work like, that time. Then he changes it and it works. And it always works. It always works. Yeah? Okay? You can always do that. Why does that work? That sounds like weird stuff, doesn't it?
Shooting for where it is.
Because it's physics. Yeah, he shoots for 2 meters. It's at 2 meters, and then he just adds 4. Kind of makes sense, though, doesn't it? Okay, here's one way to visualize why this works. Suppose that instead of being on a cliff that sits still and the car moves away from you, you're on top of a very tall car, like a truck. Yes? And that truck is following the target at the same speed as the target. Is the target moving with respect to you?
Oh, yeah.
No, it's just right there. So where do you shoot? For the target, right? 2 meters away, you just aim for 2 meters and you hit it, right? Okay. So all you have to do is aim for 2 meters and then add the speed of the car that you're moving, and that would be your speed. That's not a very good explanation. If you can think of a better one, you're good. Yeah, easy. Your ship has arrived. They need to interview you. You're so famous. So that's question number 2. Question number 3 is Vernier 3. Is this one? Okay. This is whatever we type in here is going to be the speed of it. Whatever we type there will be the direction. Okay. So if we type 90 in for the direction, what's it going to do? I like this. It's like, no, that doesn't hit it, does it? Right? Like that was a fail, right? 80. What does 80 do? Well, 80 is. Can we stop? Thank you. Okay. Yeah, 80 is way too high, right? So there is a way to calculate what that angle should be, and that is actually on this sheet. So I've got the range equation. So way number 1 is that you can use the range equation and figure out where it's going to hit. That's the v squared over g sine 2 theta, right? And it's right on there. Just show your work, show what you plugged into the formula. The other way to do it is to solve for the angle. So theta is inverse sine of whatever, and that's what we did with the rocket competition. I don't care which one you do, just use this thing to hit the target, to have the target be there. You can calculate where it's going to be, or you can calculate what angle you need to do to hit it where it is, right? But either way, don't try to do this with a T-chart like this. Just do it, use the range equation. It's way too hard to do with a T-chart. Okay, the final one, and this is extra credit. It's 10 points extra credit. Oh, and then remember that if, let's say 20 degrees hits it, what other angle will hit it?
70.
Yeah, 70, the complement of 20, right? So if 10 hits it, then 80 will hit it. If 40 hits it, 50 will hit it, right? So try both. It's kind of fun. And then, of course, the thing that's always really fun to do is to calculate something for like an 83-degree angle, right? Hit it with an 83-degree angle, and it goes way, way, way up, and it disappears off the screen, and then it comes back on, and it will hit it. That's a good one. And then the final one, Vernier 4, and this is 10 points extra credit if you can do this. It is, you're shooting it with a speed and a direction, only this is a moving target. Yes? Does that work? No, it didn't work, did it? Okay, so how are you going to do that? Well, you can't use the range equation. You kind of can use this, sort of. Okay? Let me give you a clue, and this is the only clue I'll give you, unless you ask me, and then I'll give you more. Okay, so the clue is that there's many answers to this question. Okay? You could hit it right now, like in 2 seconds, or I could hit it a month from now, couldn't I? Yes? So you must specify either where you're going to hit it or when you're going to hit it. Where or when. Okay? We already know what we're going to hit, right? So you have to tell, and so the easiest thing I think is to pick a time. Just always say that I'm going to hit it at 2 seconds. Now, if you're hitting it at 2 seconds, don't you know, I mean, you can figure out that's the vertical velocity keeps it in the air. The time hit depends totally on the vertical velocity, yes? Okay? And then if you know the speed of the car and the initial position of the car, you know where it's going to be, right? So you ought to be able to figure out for its launch velocity, right? Here it is, you're launching it like this. You ought to be able to figure out how fast to the side it needs to go to get there in 2 seconds, how fast up it needs